this lesson, we will address consumer arithmetic, which can be applied to your everyday life. At the end of this lesson, you know how to do the following. Calculate the charges shown on certain utility bills. Calculate simple or compound interest on an investment, and use exchange rates to convert from one currency to another.
Depreciation is the devaluation of the market value of any durable good due to wear and tear over time, except for antiques, which regain value. Therefore, a motor car originally valued at $600,000 is unlikely to sell for this same value after being driven for a couple of years. Rates of depreciation are used in a similar way to compound interest rates, only this time they are applied to decreasing values of the asset. Here's an example. A motor vehicle originally valued at $600,000 depreciates in value by 20% each year. What will be the value of the car after 2 years? Depreciation in year 1 is equal to 20 divided by 100, multiplied by $600,000, which gives $120,000. Therefore, the value at the beginning of year 2 is $600,000 minus $120,000, which is equal to $480,000. Depreciation in year 2 is equal to 20 divided by 100, multiplied by $480,000, which gives $96,000. Therefore, the value at the end of year 2 is $480,000 minus $96,000, which is equal to $384,000. This problem can be solved using a formula similar to A equals P times 1 plus R divided by 100 to the power of T, but with the plus sign replaced with a minus sign. That is, A equals P times 1 minus R divided by 100 to the power of T. Therefore, putting P equals $600,000, R equals 20, T equals 2, A equals $600,000 times 1 minus 20 divided by 100 squared, which is equal to $600,000 times 4/5 squared, which is equal to $600,000 times 16 divided by 25, which gives $384,000. You can now attempt the following multiple choice questions.
A principal of $12,000 invested for 5 years at 8 1/3% per annum simple interest amounts to A, B, C, or D. Which of these investments would earn the greatest simple interest? A, B, C, or D? The amount on $20,000 over 5 years simple interest at R% per annum is $28,000. Is the value of R A, B, C, or D? What is the compound interest on $200,000 over 1 year, with interest being compounded half yearly at 20% per annum? Is it A, B, C, or D? If the value of a machine depreciates by 20% each year, what would be its value after 2 years if it originally costs $500,000? A, B, C, or D?
Lesson 4. Most people pay utility bills such as electricity, water, and telephone. Calculating a water bill is not very difficult, as the only variable is the amount of gallons or liters of water used. There is usually a fixed service charge where each customer is required to pay a standard service charge to cover costs such as maintenance and inspection. Telephone bills are more complicated, where, besides the rental charge, there are rates for inter-parish, out-of-parish calls, international calls, cellular and internet service. The first question asked when viewing an electricity bill is, what is meant by the number of kilowatt hours kWh used? How do you determine how many kilowatt hours an appliance uses? This is not very difficult. Look at this example. If a 66-watt television is kept on for 5 hours, the number of kilowatt hours used is obtained by multiplying the number of kilowatts by the number of hours. Remember, 1000 watts equals 1 kilowatt. Therefore, in the above example, the number of kilowatt hours is equal to 66 divided by 1000 times 5, which is equal to 330 divided by 1000, which is equal to 0.33 kilowatt hours. Try this example. How many units of electricity or kilowatt hours are used by the following appliances? 5 80-watt bulbs, each kept on for 2.5 hours. A 1200-watt electric iron kept on for half an hour, and a 200-watt refrigerator kept on for 6 hours. The number of kilowatt hours would be as follows. 5 80-watt bulbs would be equal to 5 times 80 divided by 1000 times 2.5, which is equal to 400 divided by 1000 times 5 divided by 2, which is equal to 1 kilowatt hour. For the 1200-watt electric iron, the result would be 1200 divided by 1000 times a half, which is equal to 0.6 kilowatt hours. For the refrigerator, the result would be 200 divided by 1000 times 6, which is equal to 1.2 kilowatt hours. Now that you know what a kilowatt hour or unit of electricity means, the next question is, can you read an electricity meter? The reading shown by the meter is interpreted as follows. Dial 1 as 10 thousandths from 3 to 4, dial 2 as thousands from 4 to 5, dial 3 as hundreds from 6 to 7, dial 4 as tens from 2 to 3, and dial 5 as units or ones as 4. This gives the reading as 34,624 kilowatt hours. If your meter reader reads of this value, and the value of the previous meter reading was 34,468, this means that 34,624 minus 34,468 equals 156 units have been used during the current billing period. How is your bill calculated? There could simply be a charge per kilowatt hour used. However, some countries such as Jamaica, which have to import fuel and other commodities to produce electricity, and where foreign exchange rates fluctuate regularly, the bill would include a foreign exchange adjustment. Here is an example. What would be the meter reading shown here? If the previous meter reading was 17,284, how many units or kilowatt hours have been used during the billing period? If the rate per kilowatt hour is $1.523 and an additional 25% is added as a foreign exchange adjustment, what will be the total cost of electricity to the consumer? The meter reading is 17,533 units or kilowatt hours. The number of kilowatt hours used is equal to 17,533 minus 17,284, which is equal to 249. The cost is equal to 249 times $1.523 plus 25% of 249 times $1.523. This is equal to $379.227 plus $94.807, which gives $474.03 to the nearest cent. You can now attempt the following multiple choice questions.
How many kilowatt hours of electricity would be used by a lady using, in a period of 2 months, a 70-watt television set for 200 hours, a 120-watt refrigerator for 250 hours, and a 300-watt sound system for 40 hours? A, B, C, or D? A lady examines her water bill. She sees that she'll be charged a fixed $120 if she uses 3,000 gallons or less, and $48 per 1,000 gallons if she uses over 3,000 gallons. How much will she be charged if she actually uses 5,000 gallons? A, B, C, or D? What is the reading on the meter shown in kilowatt hours? A, B, C, or D? The sum of the charges for telephone calls made by Mr. Cellular in a particular month was $1,200. In addition, he had to pay a rental charge of $300, and on top of this, he was charged GCT at a rate of 15%. Was his total bill A, B, C, or D? A person has successive electricity meter readings of 16,342 and 17,002. If the power company charges $0.9 per kilowatt hour with an additional 33 1/3% for a foreign exchange adjustment, how much will the customer have to pay? A, B, C, or D?
Lesson 5. Most Jamaican families have relatives living abroad. Receiving remittances in American and Canadian dollars or British pounds has become quite common. Therefore, converting foreign exchange has become a daily activity. Here is an example. A young girl received US $240 from her father for her birthday. The girl scouted around and found that the most attractive exchange rate available was $42.30 Jamaican to US $1. How many Jamaican dollars did she receive? Number of Jamaican dollars is equal to 240 times 42.30, which is equal to $10,152. Here's another example. A person had 23,000 Jamaican dollars that he wished to change into British pounds. Assuming that the exchange rate was $71.50 Jamaican to £1, how many pounds would he receive to the nearest pound? Number of pounds is equal to 23,000 divided by 71.5, which gives 321.68 or 322 rounded off to the nearest pound. Suppose we are given that US $1 is equal to 45 Jamaican dollars. It is then relatively easy to draw a straight line graph which can be used to convert US dollars to Jamaican dollars or vice versa. From the graph, we can see that, for example, US $32 equals 1,440 Jamaican dollars and 1,200 Jamaican dollars equals 27 US dollars. A Jamaican resident receives US $1,600 and converts this to Jamaican dollars at an exchange rate of 45 Jamaican dollars to $1 US. He then wishes to convert 10,000 Jamaican dollars to pounds and send this to his sister in England. He does this at a local bank at an exchange rate of 70 Jamaican dollars to £1. Using the given conversion graphs, how many pounds to the nearest pound will he send to his sister, and how many Jamaican dollars will he then have left? From the first graph, 40 US dollars equals 1,800 Jamaican dollars, giving 1,600 US dollars equals 40 times 1,800 Jamaican dollars, which is equal to 72,000 Jamaican dollars. From the second graph, 5,000 Jamaican dollars equals 71.5 pounds. Therefore, 10,000 Jamaican dollars equals 2 times 71.5 pounds, which is equal to 143 pounds. The person will send 143 pounds to his sister and have 62,000 Jamaican dollars left. You can now attempt the following multiple choice questions.
A Jamaican boy receives 500 Canadian dollars from his father who's currently living in Toronto. How many Jamaican dollars would he receive if the exchange rate is 29 Jamaican dollars to 1 Canadian dollar? A, B, C, or D? Using the conversion graph which relates Jamaican dollars to British pounds at the rate of 70 Jamaican dollars to 1 pound, how many British pounds could be obtained for 3,000 Jamaican dollars? A, B, C, or D? A CXC marker is given an honorarium of 525 Barbadian dollars after marking for 2 weeks. If 1 Barbadian dollar is equivalent to 0.5 US dollars and the current exchange rate of the Jamaican dollar against the US dollar is 1 US dollar equals 40 Jamaican dollars, what would a Jamaican marker earn when paid in Jamaican dollars? A, B, C, or D?
Here are the results to the quiz questions on consumer arithmetic. Lesson 1. The correct response to question 1 is D. Answer A could be due to finding 50% of $120,000 and then dividing this answer by 600. Answer B could be the result of dividing $120,000 by 600. Answer C could be the result of dividing $120,000 by 600, then adding 50 to the answer. Answer B is the right response to question 2. You should know that probably the easiest way to find the answer is to add 20% to each of the answers A, B, C, and D. On the other hand, if the cost price is X dollars, then 120x divided by 100 is equal to $1,680. Answer A is due to finding 20% of $1,680 and then subtracting this answer from $1,680. Answer C is due to subtracting 20 from $1,680. Answer D is probably due to adding 20% of $1,680 to $1,680. You should have chosen answer D in question 3, from 40 multiplied by $180 plus 10 multiplied by $270. Answer A is probably due to the incorrect calculation 40 multiplied by $180 plus 10 multiplied by $1.50. Answer B is probably due to the incorrect calculation 40 multiplied by $180 plus $180 plus $90. Answer C is probably due to the incorrect calculation 50 multiplied by $180. The correct response to question 4 is B, from 25% of $48,000 minus $16,000. Answer A is probably due to a miscalculation in working out 25% of $48,000 minus $16,000. Answer C is due to finding 25% of $48,000 minus $10,000. Answer D is the result of finding 25% of $48,000. Lesson 2. The correct response to question 1 is C. Answer A is the result of finding just 1% of $6,500. Answer B is probably a miscalculation using the correct method of 15 divided by 100 multiplied by $6,500. Answer D is due to the calculation 15 multiplied by $6,500. The correct response to question 2 is B. The easiest method is to add 15% to each of A, B, C, and D until you get the correct answer of $138. Alternatively, if the price before GCT is added is equal to X dollars, 115x divided by 100 is equal to 138, giving X equals 138 multiplied by 100 divided by 115. Answer A is due to incorrectly finding 15% of $138 and subtracting this answer from $138. Answer C is due to just using $138 minus $15. Answer D is due to incorrectly finding 15% of $138 and then adding to $138. The correct response to question 3 is D, as $1,800 minus 30% of $1,800, that is 70% of $1,800, is $1,260. Answer A is the result of just finding 30% of $1,800. Answer B is probably the result of just finding $1,800 minus $1,500. Answer C is perhaps due to a miscalculation, either working out $1,800 minus 30 divided by 100 multiplied by $1,800 incorrectly, or failing to properly subtract the answer from $1,500. The correct response to question 4 is C, as 24 multiplied by $6,000 plus $25,600 minus $120,000 is equal to $49,600. Answer A is due to just finding 24 multiplied by $6,000 minus $120,000. Answers B and D are probably the results of miscalculations using the correct method. The correct response to question 5 is C, as $36,000 minus $9,000 all divided by 12 is equal to $2,250. Answer A is the result of dividing $9,000 by 12. Answer B could be due to correctly finding $36,000 minus $9,000, then subtracting another $9,000 before dividing by 12. Answer D is the result of dividing $36,000 by 12. Lesson 3. The correct response to question 1 is D, as interest is equal to $12,000 times 8 and 1/3 divided by 100 times 5, which is equal to $5,000. Answer A seems to be the result of just calculating 8 and 1/3% of $12,000. Answer B is only the interest earned, not the amount. Answer C could be the result of finding 8 and 1/3% of $12,000 and then adding this to $12,000. The correct response to question 2 is A. Interest is $3,000 compared with $2,000, $2,700, and $2,400 for answers B, C, and D respectively. Any wrong answers are due to poor calculations. The correct response to question 3 is B. Interest is equal to $8,000. Therefore, 8,000 is equal to 20,000 times 5 times R, all divided by 100. Answer A could be a miscalculation, thinking that 4% of $20,000 is $8,000. Answer C is the result of using 28,000 equals 20,000 times 5 times R, all divided by 100, but I is not equal to 28,000. Answer D could be the result of saying that $8,000 is 40% of $20,000. The correct response to question 4 is D. Interest in the first half year is 10% of $200,000, which is equal to $20,000, and interest in the second half year is 10% of $220,000, which is equal to $22,000. Answer A could be the result of just using 10% of $200,000. Answer B could be due to a miscalculation, using the correct method but saying that 10% of $220,000 is $2,200 instead of $22,000. Answer C could be the result of using 2 times 10% of $200,000. The correct response to question 5 is B, As the value after year 1 is 80% of $500,000, which is equal to $400,000, and the value after 2 years is 80% of $400,000, which is equal to $320,000. Answer A has taken the depreciation to be $100,000 for each year. Answer C has seemingly just depreciated for 1 year. Answer D has seemingly added 20% of the value at the beginning of each year. Lesson 4. The correct response to question 1 is A, as the number of kilowatt hours is equal to 14 plus 30 plus 12. Answer B has seemingly taken 14 plus 300 plus 12 due to a miscalculation in working out the number of kilowatt hours used by the refrigerator. Answer C has apparently just added the 3 wattages, that is 70 plus 120 plus 300. Answer D has not changed the power from watts to kilowatts. The correct response to question 2 is C, as 5 times $48 is equal to $240. Answer A has just used the fixed charge. Answer B has used $120 plus 2 times $48. That is, it was assumed that only the extra 2,000 gallons was charged at $48 per 1,000 gallons. Answer D has seemingly worked out the correct answer of $240, then incorrectly added another $120. The correct response to question 3 is A. If you gave any other answer, you should refer to this topic in the lesson. Note especially that the 10,000 kilowatt hours meter shows between 0 and 1, not between 1 and 2. The correct response to question 4 is D. Answer A has not taken into account the GCT. Answer B has just charged the GCT on the rental charge. Answer C has just charged the GCT on the $1,200 for the calls. The correct response to question 5 is C, as the number of units used is equal to 660, and 660 times $0.9 plus 33 and 1/3% of 660 times $0.9 is equal to $792. Answer A has just used 660 times $0.9. Answer B has seemingly just taken the number of units used. Answer D has seemingly taken the number of units used, that is 660, and added 33 and 1/3% of 660 to it. EPA Technologies. EPA Technologies is a software development company specializing in educational products for the Caribbean curriculum. We are committed to making a difference to education at all levels. Our vision: to become the leading developer of educational software in the region and ultimately establishing our presence in the global marketplace. The EPA Virtual Educator is the first in a suite of e-products specially structured to make the understanding of mathematics easier. With the use of graphics and animations, as well as the inclusion of an intricate array of questions and tests, the assimilation of key concepts is guaranteed. The EPA Virtual Educator. Who is it for? It is for everybody, but especially for students who want to revise for exams, students preparing for CSEC mathematics, persons resitting CSEC mathematics, or anyone just wanting to learn the subject. EPA Virtual Educator. Help yourself. Teach yourself.